Thank you for joining me today. We're going to talk about a new differentiation rule called the product rule. And it's the first rule that you're getting that really is not a basic differentiation rule and builds off of the basic differentiation rules that you learned before. So in this instance, you're actually taking the derivative of a product of functions. So f is a function, g is a function, and you want to find the derivative of their product. I want to first caution you. This does not equal the derivative of f times the derivative of g. That is an inappropriate application of the product rule. So let me write the appropriate product rule. It's the derivative of f times g, and notice g here, you haven't differentiated g. And I'm going to add to that f times the derivative of g. So the derivative of a product is actually a sum, and that's a very important fact. So let me give you an example. Let's suppose we want to find the derivative of x times the square root of x. Now there are multiple ways to work this problem. Certainly, I could actually rewrite this as x to 1 power by saying this is x to the first power, this is x to the 1/2 power. So I can actually algebraically simplify this first and write this as x to the 3/2 power and use the power rule to find the derivative here. In that case, that would be 3/2 x to the 1/2 power. But I actually want to use the product rule right now to illustrate how to use the product rule. So if I want to use the product rule on this product, I'm going to find the derivative of the first one. So I'm just going to write it shorthand like this. The derivative of the first function times the second function plus the first function times the derivative of the second function. The derivative of x is 1. So here I have just the square root of x, since the derivative of x is 1. And the derivative of the square root of x, well, in order to be able to take the derivative of the square root of x, I need to view the square root of x as x to the 1/2 power, because I don't have a derivative rule for square roots at this point. I only have a derivative rule for powers. So if I view the square root of x as x to the 1/2 power, I can use this algebraic fact to calculate the derivative of the square root of x. And the way I calculate that is with the power rule. So this becomes 1/2 x to the minus 1/2 power, because remember, when using the power rule, you decrease your power by 1. So let me simplify this algebraically, because this at first glance does not seem to be the same thing as what we have here. This is a sum, this is not a sum. So let's see if we can figure out if they are in fact the same thing. So here, 1 times the square root of x is just the square root of x. There's a constant multiplier here of 1/2, and then I also have x times x to the minus 1/2 power. From algebra, I remember when I have like bases, I can add exponents. So when I add 1 and minus 1/2, I get 1/2. This still does not seem to be the same thing as what we have when we worked the problem a different way, but it is. I can remember that the 1/2 power from this fact here is the square root. And 1x square root of x plus 1/2 square root of x is 3/2 square roots of x. So whichever way you work this, either using the power rule or using the product rule, you get the same answer. Thank you very much for joining me, and remember, if you're not having fun, you're not doing it right.